All right. Okay, so let's start to go over this. I am simplifying these two monomials. Okay, they are being multiplied together. So what do I need to do first here? Terrence, what do I need to do first? Come on, we did this yesterday. Has to do with your coefficients. What should I do with those coefficients? Don't have to put them in order, but pull them out front, okay? So I have 2 times 5, and then I have d to the third and d to the second. Those are 2 powers. So I take d to the third times d to the second, because I'm putting them together because they have the same base. Can you see that, Kalavin? You look like you're squinting. You're confused. Well, you took the test yesterday, right? So you were not here yesterday. Might want to look over the notes that we did yesterday. Not right now, though. So try to do that a little bit later. All right, so then we have e to the second, and e, there's no exponent on it, so you put a 1 on it. Okay? So e to the second times e to the first. Right now I'm just grouping them together. And finally, f to the first times f to the fifth. Okay? So 2 times 5 is 10. D to the third times d to the second. When you are multiplying 2 powers that have the same base, you keep that base and you add the exponents. So this is d to the fifth. Here I have e to the second times e to the first. You keep that base and you add the exponents. So that's e to the third. And finally, f to the first times f to the fifth. You keep that base and add the exponents. So that is f to the sixth. Final answer, 10, d to the fifth, e to the third. That is a 3. E to the third, f to the sixth. Questions on that? When you are multiplying 2 powers that have the same base, whoops, that's not the same base. You keep the base by rewriting it and you add the exponents. Okay? It's just what we do. All right. So a single red blood cell is about, I don't even know how I can say this, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions. It is 73 10 millionth meters in diameter. That is very small, a very small number. How would you write this in scientific notation? So right here is my original decimal point. For scientific notation, you don't leave it like that. Where do I put the decimal point now? Where specifically?
To the 7.
To the 7. What do you mean? You need to speak up. So is that 0.73 or 7.3? No. Yes, it needs to go in between your first 2 non-zero numbers. So that is 7.3. And if there were more numbers after that that weren't zeros, we would include them. Times 10. You can put all of that just by simply putting in that decimal, because scientific notation is a product where we multiply a number between 1 and 10 times the power of 10. Now, to get this new decimal point that I have here in blue, I need to move it to the left 1, 2, 3, 4, 5, 6 spaces to the left. Okay? As you go to the left, that is headed towards the negative direction on a number line. So 6 spaces to the left means it is going to be a negative exponent, which is going to be 10 to the negative 6. So my final answer is 7.3 times 10 to the negative 6. Okay? Did anybody happen to have that before I did? Okay, a couple of you. Daniel, let's put the phone away. Are you picking music? No, let's not do that. All right, so let's go in our notes now to where we left off yesterday. Looks like we got done with page 2 of the notes. We got done with page 3. We got down to part of page 4. So we're on the middle of page 4. Middle of page 4. Okay? So this is talking about taking a power of a power. All right? It says to find a power of a power, you are going to multiply the exponents. Power of a power, Victoria, we multiply the exponents. So for any real numbers a and any integers m and p, a to the m power taken to the p power is a to the mp. B squared to the 4th power. That means literally b squared times b squared times b squared times b squared. But nobody wants to write all that out, right? That is using this as a factor 4 times. So what we can do to simplify this is say it's b squared times 4, which is b to the 8th power. You just multiply those two together. It's almost like the distributive property. If you have an exponent on the end, you're going to multiply it by every exponent on the inside of the parentheses. So let's try this for letter A. So we have n to the 5th, that whole thing raised to the 3rd power. I don't have another power to multiply. So we take this 3 and we multiply it by every exponent on the inside. So this is n to the 5 times 3, which is n to the 15th power. That's it. Okay? Let's take a look at letter B. X to the 4th power. That raised to the 2nd power. Here's what it means, x to the 4th, as a factor 2 times. But instead of writing that out every time, we're going to say x to the 4th power times 2, which is x to the 8th power. Okay? Let's see if you can do letter C on your own. C to the 3rd, D to the 5th. That monomial is raised to the 2nd power. So if I simplify that, go ahead, do that problem on your own. What would you get? Okay, so this 2 is being distributed almost with every exponent on the inside. So that means it is c to the 3 times 2 and d to the 5 times 2. So simplifying is c to the 6th, d to the 10th. How many had that for an answer? Okay, all right. And again, we don't want to write this all out, so that's why we just multiply. All right, so letter D, here is my 3, and it is getting distributed with every other exponent, so that is a to the 4 times 3 and b to the 9 times 3 gives me a to the 12th, b to the 27th. Questions on that? Flavin, can I help you? Okay, you're good. You looked a little puzzled. All right, here, power of a product. Turn the page. Same idea, but now we have several factors. We have 3 times x to the 5th times y squared, and we have to take that exponent for every factor that we have. So to find a power of a product, find the power of each factor and multiply. We're still multiplying, okay? All right, now here is a key one. If you have a negative out front with a number, put that negative in parentheses, okay? And if you have no exponent, what is the expected exponent to be? 1. You put a 1 on it. Not a ring on it. Put a 1 on it. So my 5 has no exponent. I would put a 1 on it. X squared, my y on the inside of the parentheses has no exponent. Put a 1 on it. Okay? So this 3 is the power for every factor on the inside of the parentheses. It gets multiplied with everything on the inside. Again, if you have a negative number, put it in parentheses. So this is negative 5 to the 1 times 3 is 3. X to the 2 times 3 is x to the 6th. Y to the 1 times 3 is 3. And then when you have a number that you can actually take to a power, you do need to simplify that. Negative 5 to the 3rd power is negative 125. Okay? So let's do that with some of these problems here at the bottom. First of all, I see my 3 has no exponent. I'm going to put a 1 on it. Each of those exponents, I am going to multiply by 5. It's a lot like the distributive property. So that is 3 to the 1 times 5 times x to the 5 times 5 times y to the 2 times 5. Okay, let's simplify. 3 to the 5th times x to the 25th times y to the 2 times 5, which is 10. Should have done that in green. Okay. And here I have a number. I can simplify 3 to the 5th power. On your calculators, there should be some near you. Take 3 to the 5th power. Do you remember the little caret? So this would be 3, the little caret, 5, hit enter, and what do you get? 343? 243, thank you. 243, x to the 25th, y to the 10th. Okay. Let's take a look at B. Jump over to B. I'll leave this up here for those that are still writing. I see 2 of my factors don't have an exponent. Put a 1 on them. Put a 1 on them. So my negative 5, because it's negative, I'm going to put it in parentheses. And that is negative 5. And this 2 gets multiplied with every exponent. So to the 1 times 2, a to the 1st times 2, and b to the 4th times 2. So simplifying, this is negative 5 to the second, a to the second, b to the 8th. On your calculators, I want you to do negative 5 squared with the parentheses. Tell me what you get. 25 a squared b to the 8th. Now, I want you to do it this time without the parentheses. Do negative 5 squared without parentheses and see what answer you get. Negative 25, but that's wrong. So your calculator is only correct if you put it in correctly. Your calculator knows order of operations, parentheses first. If you don't have parentheses, it's going to do 5 to the second power, which is 25, and then it's going to multiply it by negative 1. That's why your calculator won't do it correctly. You have to use parentheses when you're taking the exponent of a negative value. Okay? Let's do these down here quickly. Down below, there's no number on it, sorry. 4 does not have an exponent. Put a 1 on it. X to the third, y squared. All of those factors are to the power of 3. So multiply every exponent by 3. So that's 4 to the 1 times 3, x to the 3 times 3, y to the 2 times 3. Gives me 4 to the third, x to the 9th, and y to the 6th. 4 to the third, you can do that on your calculator. 4 caret 3, 64, x to the 9th, y to the 6th. Questions on that? All right, do this next one again on your own. Negative 3, a to the third, b, all of that raised to the 6th power. Let's see what answers we get. See what answers we get. Yes, I saw some things that I liked. That negative 3, you really should put it in parentheses. All right. Here's what it should look like. The 3 does not have an exponent. Put a 1 on it. The a does, the b does not. Put a 1 on it. 6 gets distributed and multiplied with all of these exponents. So it is negative 3 to the 1 times 6, a to the third times 6, come on, times 6, and b to the first times 6. So negative 3 to the 6th, a to the 18, b to the 6th. What is negative 3 to the 6th power? What is it? What is it? 729. Is that right? 729? Is it positive or negative? Positive. Yes, it should be positive. 729, a to the 18th, b to the 6th. Did anybody get a negative 729? Good. Then you must have put parentheses around it or you did another little thing. Okay? Any questions about power of a product or power of a power? All right, let's move to division. Division, this is on page 6. This is what we're supposed to be on today. We didn't get all of multiplication done. Quotient of powers. Quotient implies division, an answer to a division problem. Okay? And they show you that when you do this, okay, you can expand the numerator and the denominator by writing these all out. So 2 to the 8th down here in the middle divided by 2 to the 3rd. If we write it all out, that is 8 2's multiplied together divided by 3 2's that are multiplied together. And you know that these are all going to simplify out. So what we are left with is 5 2's, which is 2 to the 5th power. That's what it means. R to the 5th is 5 r's multiplied together divided by r to the 4th, 4 r's. All of these would simplify out, and you're left with just 1 r. Okay? So when you are dividing two powers with the same base, the key is same base. Before, when we were multiplying them, we added the exponents. So now that we are dividing them, you are going to subtract the exponents. Okay? All right, so let's take a look at example 1 at the bottom. B to the 5th, C to the 7th, all divided by B squared C. First of all, I'm going to put a 1 as the exponent for C on the bottom. Diana, put that away, please. So B to the 5th and B squared. We are dividing those. They have the same base. So you keep the base and you subtract the exponents. Okay? And for my C, I have a C to the 7th divided by C to the 1st. So it is times C to the 7 minus 1. So simplifying this, this is B to the 3rd times C to the 6th. And that is your final answer. So again, this is when you are dividing powers. Now, B and C next to each other up here, they are being multiplied. But if you look here at your B's, they are being divided. If it's the same base, you subtract the exponents. All right, let's do some more examples here. This is page 7. Let's do letter A. Letter A, I have A squared. Well, first of all, I'm going to go ahead and put a 1 where I don't have any exponent, because that's going to help me out. So here I have an A squared. There is no A on the bottom. I'm just going to leave it as A squared. Right, Charles? Put that away. B to the 9th divided by B to the 8th. I am dividing two powers that have the same base. Subtract the exponents. 9 minus 8. C to the 1st divided by C to the 1st is C to the 1 minus 1. And finally, I have D to the 4th divided by D to the 3rd. Hiding it does not mean you put it away. Is D to the 4 minus 3. So putting this all together, it is A to the 2nd, B to the 9 minus 8 is B to the 1st, C to the 1 minus 1 is C to the 0, and D to the 4 minus 3 is D to the 1st. Now, This I thought would have come up in some place earlier, but it did not. Anything c to the 0 power is equal to 3 to the 0 power, which is equal to negative 32 to the 0 power. Anything to the 0 power is 1. Don't ask me why. I am not one of those big brain mathematicians. Somebody just said anything to the 0 power is 1. There is a theory and theorem that we could go through, but it's above your head, and I don't remember it right off the top of mine. So this really is going to become a 1, and so my final answer is a squared b times d. And you could keep the 1s on the b and the d, but you don't need them. Final answer. Okay? Anything to the 0 power is 1. You need to remember that. Let's take a look at letter B. First of all, you are dividing. You've got numbers. 2 divided by 8. We're going to pull those out, keep those separate for a minute. I have x to the 4th divided by x to the 9th. They have the same base, so keep the base and subtract. 4 minus 9. Trust your process. Then we have y to the 3rd. Ooh, no y, other y, so just leave it as y to the 3rd. And finally, z to the 5th divided by z to the 8th is z to the 5 minus 8. You keep the base and subtract. All right, 2 divided by 8. I can simplify that. That is a fraction. What does that reduce or simplify to? Or what can I divide both of those by? I can divide both by 2, right? 2 over 2. And that's going to simplify to 1/4. So that's 1/4. X to the 4 minus 9. We can have negative exponents. Is going to be x to the negative 5th. And y to the 3rd, that stays the same. And z, 5 minus 8 is negative 3. Now, just because I said we can have negative exponents doesn't mean we're going to keep them negative. Because if you look at all of these, there are no negative exponents. So if you have a negative exponent, and this is another thing that might come up a little bit later, okay? Z to the negative 3 means that you are going to put this whole thing down in the denominator. So it's going to become 1 over z to the 3rd. So a negative exponent moves your power to, what do I want to say? The opposite part of your fraction. Because if it was down in the denominator, you would move it to the numerator. Here, it's in the top part, and so you move it down. So what does that mean? X to the 5th here, this is going to be 1 over 4. X to the negative 5th means I'm taking this whole thing down into the bottom and making it positive, x to the 5th. Y to the 3rd, that's still going to stay on top. And z to the negative 3rd is going to go down to the bottom, z to the 3rd. So my final answer, 1 times that y is not going to change. It just becomes y to the 3rd, all divided by 4, x to the 5th, z to the 3rd. Is that a 5? Yeah, it is. So a negative exponent changes it from being in the numerator down to the denominator. Think of it like, well, I'm not going to get into that now. Maybe next week. All right, let's see, time-wise. Let's do letter C. Letter C. So first of all, we have that negative out front. That's just going to be -1. I see 3 on the top, so times 3. Now, remember how I said before, this is h to the 4th divided by h to the 4th. So before we did h to the 4 minus 4, which was h to the 0. What is h to the 0? Anything to the 0 power is 1. But let me also show you, if you have any number, or in here, any power divided by the same power, it's just going to simplify out because you are dividing the whole thing by the same amount. Does that make sense? So h to the 4th divided by h to the 4th is really just 1. Was that too much? Should we go back to the 0, 0 thing? Well, let me put it this way. If you had 5 divided by 5, you know you would simplify that out, and it simplifies to 1. So you can do this with exponents, or you can just simplify it out. So let's just write it out for now. So this is h to the 4 minus 4. This is j to the 3 minus 2. And here is k to the 3rd divided by k to the 3rd is k to the 3 minus 3. So putting this all together, -1 times 3 is -3. 4 minus 4 is h to the 0. J to the 3 minus 2 is j to the 1st. And k to the 3 minus 3 is k to the 0. We just said anything to the 0 power is 1. So this is -3 times 1 times j to the 1st, and k to the 0 here is times 1. Multiplying by 1, that doesn't change anything. You really don't need them. So my final answer is -3j. Okay? All right, let's do letter D. Okay, yeah. Let's do letter D. So I have the negative out front. I'm just going to say that's -1. I have 4 and divided by 4, so times 4 divided by 4. I have a x to the 3rd and an x squared, so that is times. When you are dividing powers, you keep the base and you subtract the exponents. 3 minus 2. I have a y that doesn't have an exponent, so I'm going to put the 1 on the bottom. Y to the 3rd divided by y to the 1st is y to the 3 minus 1. And finally, I have z squared, which doesn't have anything on the bottom. So simplifying, I have -1. What is 4 divided by 4? It's just 1, right? Times x to the 3 minus 2 is x to the 1st power, y to the 2nd power, and z to the 2nd power. -1 times 1 is -1. x to the first, y squared, z squared. If you want to get rid of the 1, it'd be negative x, y squared, z squared. Okay? All right. You can read this here at the bottom, but I'm going to jump right into the examples. Just a reminder. So if you go to the last page of your packet, we're still going to do this problem, but I want to get it out before you all jump up ready to go. The last page of your packet, the front and back, that is homework number 1. That is due on Monday. The front side is multiplication, the back side is division. But we need to talk about the power of a quotient. This is the last thing. We'll do 2 examples. Daniel, come on, head up. Charles, put the phone away. You act like this is news to you, that you shouldn't have a phone out. All right, so this first example, whenever you see any number or value without an exponent, put a 1 on it. Okay? Put a 1 on it. You are still taking a power of this quotient. Quotient meaning you are dividing, but we're taking a power. So it's still like distributing that 3. This 3 gets distributed with every exponent on the top and with every exponent on the bottom. So this becomes 5 to the 1 times 3 times a to the 2 times 3, all divided by 6 to the 1 times 3. So that's 5 to the 3rd. Come on. 5 to the 3rd. A to the 2 times 3 is 6, divided by 6 to the 3rd. On your calculators, 5 to the 3rd power, 5 caret 3 should give you 125. A to the 6th, divided by 6. That one I don't know. 36 times 6 over 216. Okay, that is the final answer there. Last one that I will do here, put a 1 on it. Put a 1 on it. 4. Do not pack up. Guys, come on. You need to know this. And I'm sorry, the time was tight here. So this is 5 to the 1 times 4 times j to the 3 times 4 and L to the 2 times 4, all divided by 7. Come on. 7 to the 1 times 4 and k to the 5 times 4. So that is 5 to the 4th, j to the 12th, L to the 8th, 7 to the 4th, k to the 20th. 5 to the 4th is 625, j to the 12th, L to the 8th, all divided by whatever 7 to the 4th is. Okay, homework due on Monday. Yes, you're going to have to work on the weekend.